Okay, on this data set, this is looking at SPS. I'm going to explain the data that is come out on page 15 to 16 of your book. They have two different studies happening. They have a study where they're calling outcome A, and a study called outcome B. And they have kids who are in a book club, kids that aren't in a book club, and basically what I'm going to do is show you why there's a difference in one scenario and there's not a difference in another. And after this, there's also going to be a session where I'm going to show you how to get the data into this and give you a little bit of practice with using something like this. But basically, there's three pieces of information that we know. And I pulled this directly off of page 16. We have students in outcome A and outcome B. And you'll notice in here I changed that to 1 and 2. Since A is the first letter, I made that 1, B is 2. The reason for that is I'm going to separate these out and just deal with one at a time. In order to separate them, that category had to be a number, so I just switched it to a number. The second issue is whether or not they're in a book club. Some are yes, some are no. So we have outcome A. We have kids who were in the book club. Here's the first kid. He was in outcome A. He was in the book club. He read 4 books. Second kid was in outcome A. He was in the book club, read 5 books, etc., 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 on and on. Then we have some kids who weren't in the book club, and they had books that they read. Now, what I want to know is for the outcome A, is there a difference between being in the book club and not being in the book club? So what I'm going to do is run something called a t-test for independent samples. And I only want to deal with outcome A first. So what I'm going to do is use this category here, or this control called select cases. I only want those students who are in outcome A. So you click on this button. It says if. And its way of setting up a control on this. I want to reset this so you can see how this works. So I'm going to select outcome, and if outcome is equal to 1, use those. You're sure that's what you want to do. When this happens, you can just close that. That's just a way. It's going to ask you if you want to save that. Don't do it. Just say no every time. Now, you'll notice these are marked out. So I'm only dealing with outcome 1 or outcome A right now. And I want to run a test. I want to analyze this. And I'm going to compare the means. And I'm going to deal with 2 independent tests. They're not paired together because it's not a pre-test, post-test. These are independent. And I want to group them based upon whether they're in the book club or not in the book club. That's called a grouping variable. So move that there. And I want to know if there's a difference in the number of books they read. Now, it asks you to define this. Well, our options are either yes or no. So I hit OK. Now, you'll notice that I had 15 students who were in the book club. They have a mean. And if you're looking on page 16, the mean is 7. I had 14 kids who were not in the book club. And they have a mean of 5. There's a standard deviation. Now, what we're looking for, there's a couple of pieces of information, and this is on the sheet that comes with this, is this number right here. And if you remember back in the hypothesis testing, we talked about something being less than 0.05, significance level. Because this is less than 0.05, there is a significant difference between these 2 groups. So I'm going to close this for just a minute. Actually, I can just reduce that. And show you this. Here's the distribution for students who are in outcome A. And this is a little hard to see on here, so I'm going to make it bigger. There. Mean was 7, standard deviation is 1.6. So this is kind of like the graph. I used a bar graph instead. of what you have in the book. And this is the normal curve laid over the top of it. So here's the people in the book club, here's the people not in the book club. And you initially think, well, those kind of look the same. 7 and 5 aren't that far apart. Well, let's look again at the t-test. There's a significant difference, and this is just like what you saw just a second ago. Because this number is less than 0.05, then that means that we can say for sure that those two sets of data are significantly different. And there's a little note on here about this kurtosis. And we'll talk more about kurtosis later, but basically, if this number is greater than 0.05, this number right here, we can assume that the shape of these two groups are the same. What this is trying to figure out is if the first group looks like the second group, because if the groups look completely different, that's going to give us a false read on whether or not there is a difference. You don't have to figure that out. It tells you. If this number for Levene's test is greater than 0.05, we can assume both groups are distributed equally. And we'll use this one right here. If it's not, this number is less than 0.05, you just drop down to this line and you can still figure it out. There's a significant difference. And what happens is if this is less than 0.05, it's just taking out the outliers on either extreme to make the two groups look the same before it runs its test. Now, here's the interesting part about this. Here's outcome A. Here is the distribution for those who were not in the book club and the distribution for those who were in the book club. And what you can see is, even though they're kind of distributed the same, there's a pretty broad separation between here and here. Those who were not in the book club have lots of books read that were down in this area that those who are in the book club don't. Now, in all static outcome B, this is what outcome B looks like. Again, the mean was 7 for those in the book club, and mean was 5 for those not in the book club. Now, if you were to just look at this, you'd think, well, 5 and 7 aren't that far apart. The reason there's a significant difference is, look at the standard deviation. They're much more spread out. And what happens is it creates a lot of overlap. Again, for outcome B, we can see in green those who are in the book club, and in blue those who are not in the book club. There's reason there's not a significant difference. I'm going to go down here to the bottom of this. And you can see the mean standard deviations. These numbers are the same as these numbers right here. This is greater than 0.05, so we're going to stay on the top line. This number, the significant two-tailed test, and it just naturally runs that. We could have made it do the other, but it'll still come out the same. That number is greater than 0.05, so there is not a significant difference in outcome B between those in the book club and those not in the book club. The reason why there's not a significant difference, again, is because of the way they're distributed. Because there's such a broad distribution of those in the book club and those not in the book club. There's just as many kids not reading books here that are not in the book club as there are kids reading books who are in the book club. Same thing up here. We have kids who are not in the book club reading 12 books. We have kids who are in the book club that are reading 12 books. And I've laid the red normal curve over the top of these. The distributions are so similar. That's why there's not a significant difference. The problem that people run into in schools, and not just schools, but anywhere, is you can't look at these numbers. Anybody could run a mean on the number of books that a group reads. And some people might say, Just if all they had was this information, is I had 15 kids in the book club and they read 7 books. I had 14 kids who were not in the book club and read 5 books. Some people might say, yeah, it makes a difference. Some people would say, no, it didn't make any difference at all. You can't know unless you run a statistical test whether or not there's a difference, because it's not just about the means. It's about standard deviations too, how they're distributed. It's also about the distribution shapes. Because down here we have the exact same means, but because the standard deviations, it keeps popping up, I apologize for that, because with the standard deviations are so much broader, it creates this overlap. But unless you run a statistical test, you can't figure it out. And even having the standard deviation isn't enough. You have to run a t-test to really figure it out. This is what, in a lot of places, is not happening when people make decisions. They don't know this information. They don't know how to figure it out. That's the purpose of this course. That's going to wrap up this part because I'm going to run out of time. These videos have to be less than 15 minutes. Next video is going to show you how to take raw data and get it into SPSS.